Good morning, ladies and gentlemen. Today I will be taking you through lecture 8 and lecture 9. Remember last week we talked about arrays. So today we're going to talk about modular code, which is part of lecture 8 and lecture 9. So in this lecture we'll be talking about the functions mainly, and then talk about local global variables, talk about encapsulation. Then we learn about passing arguments to functions and return a value from the functions. So let's start. I have prepared some PPTs for you here, which I will share them with you. Let's talk about a function. What is a function? Let me slideshow right from the current. Let's talk about a function. What is a function? So a function is a set of statements. You remember we talked about statements when we were writing statements in our programs. That takes inputs to do some specific computation and produces the output. It provides the reusability of the code, meaning when you create a function, the same code can be used maybe in different programs, yes, or different classes. We can also easily modify code using the methods or the functions. To perform any task, we can create a function. A function can be called many times, meaning if we have number of functions in a program, if you want to use the same function in different function, can call a function inside another function. It's possible. It provides modularity and reusability. So if the program is very big and we want to break such kind of program into smaller pieces, whereby each and every programmer can be able to work on a certain portion of the program, then we can use the function so that the program can be modularized and the code can be reused. If we are building a different system but we still need that kind of a function which has been used in another program, then we can just take such piece of code and use it in a program that we are trying to build. So that is reusability. That means that we can still use that code again and again in different programs. That's what it means. So code reusability, that is the advantages of functions. By creating a functions in C++, you can call it many times. I've already explained that. So we don't need to write the same code again and again. Code optimization. It makes the code optimized. We don't need to write much code. Abstraction. Functions provide abstraction. For example, we can use library functions without worrying about their internal working. So it can hide some details to other maybe programs, like the internal functions, like some attributes, like some, so that is the abstraction. We have different types of functions. We have library functions, are the functions which are declared in the C++ header file, such as clex, cosx, exponential, and etc. So when you call the libraries in C++, such as maybe the math library, you can get all these functions. These are called the library functions. They are already predefined. They are already there in the header files. So the only thing that you need to do is just to use them. You don't need to implement them because they are already there. So we have user-defined functions. These are the functions that you as a user, you define them. Are the functions which are created by the C++ programmer so that he or she can use it many times. It reduces complexity of big program and optimize the code. So right now we are going to do our own functions, create our own functions so that we can be able to use them. So declarations of functions. So this is how we declare the functions. First thing that you do, it's a data type, the return data type. You provide the data type. It can be void, it can be integer, can be any other data type, it can be char, character. So you just provide the return type of your function, then the function name. Provide the function name. It can be prime number, prime. It can be sum. It can be maybe finance. It can be, just give any name of that function. So data type and the parameter. So we have some parameters that this is what you call the passing of the parameter. So some function they can have they will have some parameter. So when you provide the parameter, maybe it can be the data type such as int x. You'll see some examples when we talk about that. Then within the function, open this curly braces and close. Then the code, whatever the function that we want to the task that we want to perform with this function, we just write those statements in here. So a function declaration. A function declaration tells the compiler about the number of parameters. Yes, if you provide the parameters, it evaluates on how many parameters are supposed to be here. Functions takes data types of parameters and return type of function. So a return type of function, is it an int or is it char? Yes, or is it void? So when it's void, it does not return any value. Putting parameters names in function declaration is optional in the function declaration, but it is necessary to put them in the definition. We have an example here. This is our C++ program. So this is our header files. Hash include IOStream using namespace standard. Then we have our function. Our function is called max. So max, it simply means that it's a function that will help us if we have two numbers. We want the program that will tell us among the two numbers which number is the maximum, or is the greater, the maximum, like the maximum value. We want the maximum value between the two values that we get as our parameters or as our input. Then we find the maximum value. So here, when you look at this, we have int x, we have int max. This is a return type for our function max. Then we have int x. This is our parameters. This is a return type for this parameter, which is x. This is a return type for this parameter, which is y. So we check, we open the curly braces, then we check, we say if x is greater than y, then we return x. Remember our function return type, it's int, so we're going to return this value. Else return y. So what does this statement mean? We are saying if the value of x is greater than the value of y, then return x, else return y. This is the function that we created, which is called max. We also have another function here, which is called the main function. Remember, when the program runs, it runs from the main function. Each and every C++ program, it must have the main function. So we have int main. Now we start to declare our variables here. So we declare our variables and assign them values. So we are going to say int a, and then we assign it to the value 6. We have int b, and we assign it to a value 5. Then we declare another variable, int m, which will hold the values of our function, which is max. So we call this function, this is max. This is how we call the function. This function is outside the main function, if you look at that. But we call this function inside the main function so that we can see the output or compute whatsoever that is going on within this. So when we call this function, we pass our parameters here, which is a and b. Then a is 6, b is 5. Then what is this function does? What is the work of this function? Remember, we talked about this. It checks between the two values given. It checks which one is greater. That means if x is greater than y, return x, else return y. So we call this function here. Then we see out m, which is our variable, which holds the values of our max function. Then we return 0. So the output here is going to be which value is, because a is greater than 5, which means a is greater than b, then this program will definitely output 6. That's how it works. So we have another function here. We still talk about calling the function. So we can call, remember we talked about calling this function inside the main function. Then we can call a function inside another function. So we have 3 functions here. We have void work function, that is a return type, is void. We have void test, this is another function. Then we have int main. So what is going to happen here? We are going to call, we have this function and we call this function work. Function test. Then inside the main function, we also call the test function. What is going to be the output? The output that we are going to get, because within the test function, we have returned a work function, which means we have returned the void. This is void. Remember, when you talk about void, we said we don't return any value. So we have returned the work. So return the work function, which is this function up here. Then what is going to be the output? The output is going to be see out the void function has returned, maybe the void value. So this is going to be the output on this program. I still believe this is clear. Let's talk about parameter passing to a function. The parameters passed to a functions are called actual parameters. For example, in the above program, 10 and 20 are actual parameters. But for now, here we didn't use 10 and 20. We used the 6 and 5. 6 and 5 here are the actual parameters. So you get the difference between the formal parameters and the actual parameters. So the actual parameters are 6 and 5. The parameters received by the function. Remember, we have this parameters received by the function, which is x and y. This is our function here, x and y. They are called the formal parameters. For example, in the above program, x and y are formal parameters. There are 2 most popular ways to pass the parameters. So you need to understand the actual parameters, what is the actual parameters, and what is the formal parameters. So we, like I said, there are two most popular ways to pass the parameters. We have we can pass by value or pass by reference. So when we pass by value, in this parameter passing method, values of the actual parameters are copied to the function's formal parameters. Just get this right. When you pass by value, it means that values of the actual parameters, remember we talked about the actual parameters. Now, what are the actual parameters? We talked about 5 and 6 are actual parameters, are copied to the function's formal parameters. What are the formal parameters? We talked about x and y are our formal parameters, and the two types of parameters are stored in different memory locations. So these two types of parameters, they are stored in different memory locations. That is what when you talk about, that is that's what it means when you talk about pass by value. So any changes made inside functions are not reflected in actual parameters of the caller. I think that is very clear. So pass by reference. So some of these things you won't understand them well now, but by the time you do C++, you will get to understand them. So here I'm just introducing to them. Both actual and formal parameters refers to the same location. So with these ones, both the actual and the formal parameters refer to the same location. So any changes made inside the function are actually reflected in the actual parameters of the caller. Ugulo is different. They are not reflected, but this one, they are reflected in actual parameters of caller. So let's talk about the variables, which are global and local variables. Remember we talked about the variables when we started, and declaring variables, stuff like those ones, and we know what is a variable, which is the memory locations. So we have global variables, and global variables are declared outside any function, and they can be accessed, used on any function in the program. So with these ones, they are declared outside any function, and they can be accessed on any function in the program. So that's what it means. So now you know when you talk about functions, what are we talking about? So when you declare the variables, what are we talking about? You know how to declare the variables. So with these ones, you have to understand when you say your variables are global variables, they are declared outside the functions. That's what it means. So declaring a global variables are usually declared outside of all the functions and blocks at the top of the program, mainly at the top of the program. They can be accessed from any portion of the program, meaning when they are there, they are global. They can be seen by any function anywhere inside that program. So we have local variables are declared inside the function. These are declared inside the function and can be used only inside that function. And it is possible to have local variables with the same name in different functions. So if we have a function, maybe sum, we have another function, maybe even numbers. Then this one for sum, it calculates the sum of numbers. This one, it checks the even numbers. So you can have a variable a and have a variable a with the same name, but those variables can be found in different functions. When they are like that, they are the local variables. They are declared locally within each function. So when they are there, they cannot be accessed by any other function apart from the function in which they are declared in. I hope that is clear. Let's make an example so that you can understand when you talk about global and local variables. So this is our program here. We are just demonstrating the global and the local variable. So here we have this is our header file using namespace standard. Then we declare our global variable. We give it a return a data type int and give it the name global. Then we assign it to a value 5. So this variable can be used anywhere in the program, can be accessed by any function within the program. So here, when you look at this is the main function. And then we declare another variable here, which is called global. But this variable here, it's a local variable. It's a local variable because it has been declared within the main function. We can have another function called sum, and we can declare the same variable inside that function. Then that variable that has been declared in that function, it's local variable. It's a local variable. So I still believe that is clear. So now you can see this variable is global here, and this one is local. So let's talk about encapsulation. What is encapsulation? Encapsulation is defined as a wrapping up of data and information under a single unit. So we for now will not talk about classes, because you don't know what's the use of the classes. But the moment you start talking about the classes, I will show you, I will make an example so that you can see how do we encapsulate or wrap our data, or how do we do encapsulations. So in object-oriented programming, encapsulation is defined as binding together the data and the functions that manipulate them. So encapsulation also leads to data abstraction or hiding, as using encapsulation also hides a data. So the advantages of data abstraction: helps the user to avoid writing the low-level code and avoids code duplication and increase reusability. Can change internal implementation of class independently without affecting the user, and helps to increase security of an application or program, as only important details are provided to the user. So you can start implementing your own functions. So here is the program that I have just created, the one that we talked about in the example there. Let me do this. Let me demonstrate. So let's start and create our own function. So this function is going to add two numbers, then give us the sum. So let's call this function sum. Int sum, this is the name of the function. So what is going to happen with this function? This function, let's pass the parameters within this function. We can leave it empty like that, there is no problem. We can just say, let's start declaring our variables inside the function. You just decide the way you want to do it. Int a, oh, sorry, my battery, I mean charge. Yes, so let's say int a, then int b, then we say int c, is equals to A plus B. Then we return C. This is the function that we have. Then we create our main function. And call that sum functions our main function. Okay, let's do this. Let's do this. Give it values. Maybe it's 4. Maybe it's 5. Yes. Then we call our sum. Let's do cout sum. We call this function inside our main function, and we want to see what is going to be the output. So you can see now the sum is 9. 4 plus 5 is 9. So it means that we have our main function. So we called the sum function our main function. So we have done this program, meaning all these variables that you see here, they are declared within the sum function, meaning they cannot be accessed anywhere except inside the main function. So let's try maybe to access those variables and see what is going to happen. Maybe cout A. We are going to get an error because A was not declared in this scope, meaning A is not accessible inside the main function, but it's only accessible inside the inside this variable, inside this function, which is the sum function. So let's declare A globally here on top. Now you get to understand when you talk about the global and the local variables. So here they are declared locally, but when we declare them up here, they are global. They can be accessed within this function. So meaning A, we can say int A is equals to 4, or is equals to maybe 10. So this A, it's used in this function, which is sum, and this A will also be used in this main function. And simple means that we are going to see we're going to get, okay, let me start with this one, cout A, then we see the output. So now you can see the value of A is 10 because A is global now, can be accessed by the main function and many other functions inside the program because it's global. So let's do sum. Let's do sum, but receive this A global so that we can see what this A is accessible here. So it means that A plus B, which is B is 5, the answer is supposed to be 15. So let's see. You can see here the answer is 15. So it means that the global variable can be accessed anywhere within the program. So let's write the same program, but this time okay, let's create another function here and give the parameters to the function. So let's say int what's the name of your function? What can we call it? This is the function that is going to give us an it will give us an area of a rectangle. Let's say that. Okay, let's call it rectangle. Rectangle area, that is the name of your function. So it's going to take two parameters, which is a height and the width. Height and width. Then we say int area is equals to height times width. Height times width. That is the area. Then we return area. Then we return area. Let me remove this because I received this. So from the main function, let's call our rectangle area function, which is this one. But before we call it, let's declare some variables in here. Int a is equals to 4. Okay, let me not write a. Let me see. Length is equals to 4. Int width is equals to 5 or 6. Let me say 6. So I say it's a 5, not gonna go fair. Then we say a length width So let me say int area is equals to this. We call this function. Then cout. So you need to understand this area that is being used here is not this area. We can call it area of a rectangle. Area of a rectangle. So we cout area of a rectangle, which is this one. So we called this function, which is a rectangle area, which is this one, which does this computation height times width. Then we return this area, then we call it here, and then we pass this parameters in here. Let's return. Let's see. So now you can see 4 by 6 is 24. So this is how we declare the functions. This is how we implement the functions. This is how we create the function. This is how we pass the parameters into the functions. Declare our variables as global and local, and we talked about the encapsulation also. So this marks the end of our lecture for today. So let's meet on our next lecture. Thank you.